This demo illustrates how a CAE analyst can work with geometry not native to NX, make design changes using synchronous technology, and not lose any work that was done when they import a new version of the part. The first task is to import a step file, version 1 of the part, into NX. The part will load off of the screen, so you will need to perform a fit command. Next, double-click on the item in the Part Navigator and rename it to version 1. Next, go into Advanced Simulation and create a new FEM. Give the FEM a name and then click OK. On the new FEM pop-up window, it is critical that you select No Bodies for the Bodies to Use option. Make the eye part the active part, and then return to modeling. Now create a wave link using the Wave Geometry linker. Select the imported geometry as the body. Make sure Associate and Hide Original options are both toggled on. Next, you will perform a series of 4 design changes using synchronous technology commands. The purpose of these commands is to simplify the geometry and make it suitable for meshing. First, use the Make Coplanar command to remove a small lip in the model. This lip is of little consequence to the analysis, but will make meshing difficult and possibly lead to poor quality elements. Next, use Move Face to pull a large portion of the cover down to match the other section. For this option, you will measure the height of the lip. The default direction is to add material, so click on the reverse direction icon to remove the material. Now use Pull Face to remove a small counterbore feature. If you zoom in on the part, you will get better drag control for the change you are making. The final change will use the Resize Face command to reduce the diameter of a large hole, thus adding material to the part. The small lip resulting from the hole being close to the neighboring vertical wall will result in very small elements in the local area. This could lead to poor element quality and reduced accuracy of your finite element results. Return to Advanced Simulation and make the FEM the active part. Right mouse button click on the FEM and select Edit. Pick Edit Bodies to Use and make sure the Select Bodies option is toggled. Select the part shown in the graphics window. Now create a tetrahedral mesh on the part. Make sure the element size is set to something reasonable, such as 8 mm. Too small of a mesh will take too much time to process. Too large of a mesh will lead to poor quality. Once the mesh is complete, zoom in on and rotate around the part to give the audience a feel for the mesh. When done, click on the CAD model to make it active and return to modeling. Now import the second version of the model. This file is also a step file from another CAD authoring tool. Once the model is imported, show that the difference is that the new model has a second radial rib near the large hole in the lower left corner. Once again, rename the body in the Part Navigator, this time to version 2. Return to Advanced Simulation and double-click on the eye part to make it active. Now go back into Modeling. In the Part Navigator, right mouse button click on the Wave feature and select Edit Parameters. Change the body that the eye part is wave-linked to by carefully selecting the version 2 body. This can easily be accomplished by selecting the second rib from the new part. Please note that the two parts are now overlaid on each other, so be careful to select the correct one. Next, click on the Replacement Assistant. A dialog box will appear. Just click OK to remove it. Now pick on Find Geometric Matches. NX will now inspect both parts and generate a list of matching edges and surfaces. In the Correspondence list, you can scroll up and down to show the list of matches that were found. Click OK to accept the matches. Make sure that Hide Original is selected on the next form, and click OK. Notice that version 2 of the body has been updated to incorporate all of the synchronous technology design changes that were done on version 1. This is handled by the wave link that was created, with the eye part originally being linked to version 1, but subsequently being changed to link to version 2. In the final part of the demo, return to Advanced Simulation and update the mesh. Make the FEM the active part. Zoom in on the ghosted outline of the second rib from version 2 of the model. Note that the geometry takes into account the new version of the model, but the mesh has not been updated yet. Right mouse button click on the FEM in the Simulation Navigator and note that the status is Update Pending. Update the mesh and show the area of the new rib, how it has been meshed to reflect the new geometry. This concludes the demo.